Okay, so hello everybody. Please join me in welcoming John K. Thompson. John is an international technology executive with over 30 years of experience in the business intelligence and advanced AI analytics fields. Currently, John is responsible for the global advanced analytics and artificial intelligence team efforts at CSL Behring. John is also the author of Building Analytics Teams, Harnessing Analytics and Artificial Intelligence for Business Improvement, and Analytics, How to Win with Intelligence. I'd like to thank John very much for accepting the interview. It means a lot to us as a young and growing AI community. Really need the point of view of countries and ecosystem and people that have much more experience in business and AI and analytics, and also building the infrastructure around that. Thank you very much, John.
Thank you, Gabrielle and Ujin. Happy to be here. So excited for the conversation, and I'm looking forward to your questions and questions from the audience as well.
Yeah. So, let's, maybe start a bit lighter. What inspired you to dedicate a book to building analytics teams? How is this different from, any other team to some extent?
Sure. Yeah, I've been doing this, as you said in my intro bio, for over 3 decades now. And I've gone all the way from data management to business intelligence, data warehousing, descriptive statistics, predictive analytics, artificial intelligence, prescriptive, all the way up to simulation and optimization. So I've done this in 20 different industries. I've helped deploy 60 different predictive applications into production. And I've probably made every mistake you could make along the way. And I thought, man, this is just rough, going on all these dead ends and making all these mistakes and everything. And I thought, I'll just write this all down, in a book and put it out there. And hopefully, people like, the folks here that are on this call can read the book and then not make the same mistakes I made.
Okay, but just to give us a bit of insight, what would you say is different, what makes analytics teams so different than, let's say software teams or something that's quite, they relate with and they work alongside with. So, why would you bother to have like a different culture or different methodology or a different way of viewing analytics teams?
That's a great question, Gabby. The analytics teams, if you've read the book, that I talk about this quite a bit, that analytics teams are not like software development teams. They're not like IT teams. It's not as if someone is asking you to build a data entry form that I'm going to start out at A and I'm going to end up at B and it's going to take me 3 weeks to do it. It just doesn't work that way. It's not something that lends itself to an agile methodology or those kind of software development methodologies. It just doesn't work in this environment, because analytics teams and analytics projects, if you really want them to be as successful as they possibly can be, they're more like a painting. They're more like a creative endeavor. They're more like trial and error than anything else. And I have that conversation with people outside of our area, with people in IT, people in executive management, people in all sorts of areas, running supply chain or manufacturing or marketing or things of that nature. Sometimes, and I try always to have my team out on this edge of innovation. We're bringing together different sets of data and we're integrating them together in new and novel and interesting ways. And we're trying, what we're really trying to do in our projects, and hopefully, everybody here is trying this too, is we're trying to build computing and data-based models that are as representative of real life as possible. So, you may be bringing together 10, 15, 20 different data sources. You may be stringing together 6, 7, 8, 9, 10 models. Our brains are so complicated and complex. If we're really striving to have a somewhat similar representation of the real world in a computing and data environment, it's really hard to do. So I explain to people, we are going to go down dead ends. We are going to fail. We are going to try things that do not work. So I can't tell you it's going to be 6 months, 8 months, 3 weeks, 2 days to get this project done. I can tell you it's going to be somewhere between 4 months and 8 months. And that's hard for some people to get their head wrapped around. But usually what I do tell them also is that, okay, I'll give you a real world example. We just did a forecasting model and we extended it beyond its original purpose to go into labor forecasting. What we found so far is that we forecast labor really well based off the previous forecast that we did. And if we implement it across the entire network, we're going to save somewhere between 25 and $34 million a year. Now, when I tell people that, they're like, I don't care if it takes you 4 months or 8 months to get it done. Just go.
Yeah, definitely. I've heard similar things before. um, Also, like tying a bit to this, seems a lot of things like research, like innovation, a lot of things where, yeah, a lot of dead ends, a lot of creativity needs to happen. And so my next question is a bit about what's the importance of diversity in a team, and what kind of diversity do you recommend? For sure, gender diversity might just not be enough. How do you like kind of see the whole picture of it? Because when you kind of build a model, there's a lot of known unknowns and unknown unknowns you kind of need to take care of. You can't just say I'm going to let it loose in the wild and figure it afterwards.
Yeah.
So yeah,
See what
how
happens.
can you kind of build around diversity, in a team, and what kind of diversity do you recommend, or how at least you can check are you in the right track or not?
Yeah, it's a great question. No matter how big the team is you have, it's almost impossible to have all aspects of diversity covered. Yes, there's gender diversity. There's in the United States, there's a hang up on racial diversity. I think a lot about age diversity. I like to have young people on my team, people who are in their undergraduate work, people who are interns, people who are just out of undergraduate, maybe PhD students and graduate students and folks like that. So age diversity is very important to me. And then geographic diversity is very important. Americans think differently than do Canadians, think differently than Romanians, think differently than Brits, think differently than Finnish, people. I like to have a lot of geographic diversity on my team. I can't get all those dimensions and all the other dimensions too, neurodiversity. You can't have it all in one team. They just won't have that many people. So what I try to do is we have project teams, but we augment them with subject matter experts from our business. So people in manufacturing and supply chain and all those kind of things. And we try to bring in the smartest and the most experienced people from those teams, but we also look for any axes or dimension of diversity that we can bring to the team. So it really does make a big difference if you have a diverse team from all the different perspectives, because I'm a 62-year-old white man from the Midwest of America. I have a certain mindset. I'm sure Oriana has a completely different mindset than I do. So as we're going through our projects, she's going to bring up things that I probably never even thought of. So it's hugely interesting and important to have diversity if our objective is, as we just discussed a few moments ago, building computing and data models that are as accurate and repeatable as possible to give us representations of what's going to happen in the future, predicting the future. We need significant amounts of diversity.
Yeah, to follow up a bit on that, in Eastern European countries, it's very hard for us to get certain types of diversity, and probably also for you. I mean, you say, oh, but they're data scientists, for sure you won't have income diversity, so other things, people kind of, you're still somehow, boxed into the people you have to work with, and my question is, how do you detect the gaps, and how do you cover your blind spots? Can you even cover your blind spots for diversity, or or at least blind spots in general for your model, if not necessarily for points of view, kind of?
Yeah, it's challenging and it's interesting. I ran the advanced analytics division of Dell for a few years, and we did a project for Telnor, which is the Norwegian telephone system. And most people are like, yeah, okay, making calls, mobile phones, pricing plans, yada, yada, yada. But what they wanted to do in this project was to understand bill payment behavior and credit worthiness in the third world. So in Bangladesh and Pakistan and places like that. And we did some really interesting projects, and we brought in people from those areas who were managers on the ground, who were understanding the actual population. Because I certainly don't have a lot of background genealogically or ideologically with poor chicken farmers in the back country of Bangladesh. But they brought the perspective of this is what matters to these people. This is what's important to them. And we could imbue that in the project. So even the people you're building the technology or the models for know people that you don't know. So you can bring them into the mix, and they can, by proxy, explain to you the world you're trying to serve. So it just doesn't have to be people on the team or subject matter experts. It can actually be a chain of people that take you further away from your experience into the world you're trying to impact.
Yeah, okay, makes sense. So technically, getting outside help, kind of not seeing it as a, your team effort, but kind of trying
Mhm.
to actively pursue it and actively like try to, cover at least the, like you said, the basic things. You cannot be in the mind of someone who you're so far away geographically, culturally, income-wise, and everything else. At some point, they're definitely, just guessing.
Yeah,
Okay.
you are just guessing. And we were lucky. We were able to get an understanding of what was important to these people. They're walking a day to go to a bank branch to withdraw a handful of rupees. So we understood it. We did the modeling. There was a certain part of that population who were very credit worthy and very responsible. They were able to extend microcredit to them, and it changed their lives. Changed the economic success of villages in totality. And Telenor won 3 or 4 international humanitarian awards for it. And I learned a lot because I thought, I really don't know how to help, subsistence level and chicken farmers in Bangladesh. But in the end, we were able to.
Yeah, makes sense. How do you build, for example, a healthy culture concerning ethics? Generally, maybe around analytics, but also in your team and, kind of maybe your managers or your
Mhm.
peers.
Yeah, that's a great question, Gabby. I was thinking about this the other day, and I've been doing this for a long time, as we've talked about already. And it used to be, people would ask data analytics and people like me to do things that I just thought that's not right. You shouldn't do that. Just because we can do it, we shouldn't do it. I mean, the first job offer I got out of college was to write code for the guidance systems of cruise missiles, and I couldn't do it. When they explained to me what the job was, I just couldn't take the job. And they looked at me weird, and they're like, why? You're just a programmer. And I'm like, yeah, I'm a programmer writing code to kill people. I can't do that. So early in my career, it was just one of those things that I thought, just because we can do it doesn't mean we should do it. Now, decades later, in my team anyway, or at least in most of the teams I've ever been involved in, ethics and responsibility and ethical responsibility is a backdrop in everything we do as data scientists. So, we may be getting data, we may be integrating it together, but we have to understand what that data is, where it came from, what it's going to be used for, what the purpose is. It's responsible on us as individuals, me as a data science leader, and the companies that we work for to make sure that what we are doing is ethical and responsible. And we can do, and people do bad things. There's no doubt about it. We've all read about
Yeah.
Facebook and Cambridge Analytica. Individuals will do underhanded things, but each of us as an individual has a responsibility to treat data fairly and ethically and be a good citizen and do things that are right. That's my personal belief anyway.
Yeah, and also what I've seen, for example, a bit of a movement, analytics and AI can't really like live in a void. Generally, you need teams, you need people that know people, you need outside experts on very specific things. And what I saw quite a grouping between proliferation and non-proliferation, people that are pro or con. And I saw that this divide kind of also pushed a lot of people to, first of all, make up their mind. Second of all, kind of decide what they're going for. And even entire companies like, Google is very non-proliferated. They say we're not going to weaponize it. And, Amazon and others said they will. So, also kind of this divide, I saw it works a lot because the better minds are kind of moved around it and they're kind of, against it because, there's peacemakers and generally people are not. So this is kind of another way to stranglehold like unethical or people that don't really want to play along, also by kind of trying to be very open about it, also at least from me with my managers and everything, be very open with, listen, we're not going to do this. I am going to refuse. I am going to resign, and always kind of push back, because
Yeah.
it's very easy to go into a mindset. Yeah, but how much harm can it done? Like you're a program, like you said, you're a programmer. You just build a guiding system. Yeah, but you aren't.
No, you're
To some
not. You're killing
extent.
people. You
Yeah,
have you
to
have
some
to be
extent, you
aware.
aren't.
Yeah.
Also, at the
The,
same
the
time.
the better job you do, the more people will die. That's
Yeah.
not good.
Okay. So like this is a bit of a preamble, but currently the best ML video and language models are trained on millions and millions of images, video, text that are generally loosely curated. But some works and a lot of really recent work show that a smaller set of data, but much better curated, leads to the same performance or even better. And so now you have to transfer the need of lots of compute to the need of investing a lot in curating this data and having less compute. What's your kind of stance on this? What's the balance? Should you just throw random data, let's say, at a language model and just hope it works? How much should you invest? When investing too much is enough? Maybe close to the 80-20 rule, or maybe another rule. How do you kind of gauge this idea of, we have a lot of data, but how much is enough? How much should we look at it?
Yeah, that's a great question too, and it's something that the industry is evolving through. Yeah, it used to be, I've got a billion images of big yellow school buses, and that's what we have in the United States, and we stack them on their back and lay them on their side and put them on their nose and photograph them tipped over and all this other kind of stuff, so the model can recognize a bus no matter what form it's in. And that used to be the state of the art. I've been working my current job for about 4 years now, and I work for a biopharmaceutical company that treats rare diseases. And what the reality of this job is that it forced us as an analytics group to work with much, much smaller data. We were just forced to. We didn't have any other choice. So we had to be out on the leading edge of that trade-off that you were talking about. We just didn't have the billions of images and the billions of rows and the billions of instances. We had a few. We had a handful. So we didn't really have to go through the curation step of taking the billions down to the hundreds or thousands. We were just thrown into the thousands. And what we have found out is that our models outperform those that are using billions of instances. We've spent more time on the algorithms, more time on chaining models together in an ensemble approach, and a better time understanding the data itself and engineering the best possible features. So I would say, even if you want to take this a little further afield and say, for global warming's sake, it's better to spend more time on the data curation, the feature engineering, the model approach, and you will get better results. And you won't be using hours and hours and billions and trillions of compute cycles. The first approach, was great, and it got us down the path of where we've gotten to, but it is a little lazy. I'm just going to throw a truckload of data at it and see what happens. That's a little lazy.
Yeah, but we also probably kind of got for free also the compute
Oh
for
yeah.
it.
Yeah,
Yeah.
absolutely. Yeah, there's
So
no doubt. I mean, when you're Google, a trillion compute cycles is nothing.
yeah,
It's like, okay, we'll burn it.
yeah, because I actually talked to you this about, but people weren't joined. I kind of joined the data, the recommendation systems kind of in 2010, and that was the idea of, oh yeah, let's build a system that can predict movies. What movie you're gonna rent next. Kind of Netflix was starting, and that
Yeah.
was the thing. You could never have thought of a lot of cycles. GPU compute wasn't even there. So this idea of scarcity was much more frowned upon. It was much more, that was the reality. So you couldn't say, yeah, we have trillions of data, trillions of raw billions. I know, just throw the data there and see what happens. And in the meantime, you're right. We kind of shifted from, let's take really good care about cycles. Let's really prove things mathematically. Let's make sure things are bounded. Let's look a bit at the data. Check for outliers. To how much data do we have? Can we have more? Let's throw it into the algorithm and see what happens.
Let's
So
just
yeah,
shovel it in there.
yeah. And yeah, you're right. It's a bit of a wishful thinking that throwing more data at some point means to some extent more knowledge.
Yeah. Exactly. It's always been one of those things that, when I started my career, and I was an assembler programmer, if anybody even remembers assembler. So I was writing code and building systems, and then I wrote in a bunch of different languages, But it came very clear to me, within the first few years that everything I did came down to the data. It doesn't matter if I was writing this kind of system or that kind of system. It all came down to the data. So I started, on this path probably 3 or 4 years after I graduated. So that puts it at like 34 years at this point. And I was at O'Hare Airport, which is the big airport here in Chicago. And I was standing at a gate waiting to get on a flight. And I turned and looked to my right, and it was my old manager from IBM, and I hadn't seen him in, like, at that point, 5 or 6 years. So I kind of nudged him, and he, startled, like, who's hitting me, who's pushing me, who's touching me, so we both laughed, and we had a good chuckle, and we caught up on our families, our daughters and dogs and all that kind of stuff. And then he said to me, as we were getting ready to get on the plane, he said, all those years ago when you were going on and on about data and analytics, he said, I thought you were crazy. And I said, no, I was just early to the party, that's all.
Yeah, definitely you can get glimpses of that. So another preamble, a lot of analytics ML work is done in very clean settings, like sanitized, balanced data sets and everything. How easy is to take these things and use them in practice? Like you said, for pharma model, to some extent you kind of work on a data set, you clean up a lot, and then you kind of release your model to the real world. How easy do you think this is, and what you should really be looking for?
Yeah, Gabby, it's a real challenge. There's no doubt about it. And it's not the models, it's not the technology, it's the business people that's the challenge. It's the IT people that is the real challenge. We've done things where we've created our own data sets and we've built models, and we found that it doesn't work, in certain instances. We've tried to do things that were way out on the edge of innovation. It just not possible. It will be in 5 years, but now it's not. So we've built, in the last 4 years, I think we've built 27 predictive analytic applications in the role that I'm in right now. We've gotten about half of those into production. And some of the problem, begins at the very first meeting, the very first conversation. And now I'm smart enough, after even making more mistakes, that I sit down with people and I ask them, these executives, these are C-level executives, CEO, COO, CFO, or senior vice presidents or executive vice presidents. And I asked them, I said, do you just want a number? If you just want a number, that's a project. We'll give you a number, and that'll be 3 weeks and we'll be done and you won't hear from us anymore. Now, do you want a number, or do you want a continuous improvement of your business? Do you want this process to get better over time? And most of the time they say to me, I just want a number. And I'm like, okay, fine, we'll get you a number. And then they'll come back usually 3 months, 2 months later, and they're like, I'm intrigued about what you said. The number, that's a project. The continuous improvement, that's a program. And I explained to them, project, you don't have to do anything. We'll give you the number. A program, you have to work with us. You have to be engaged. You have to understand what we're doing. We have to automate the data flows, build the models, and change the way you do business. If you're up for that, then we're in for it. And we will build the models, and we will maintain the models, and we will help you change your business. And we'll help you transform and re-engineer whatever process it happens to be. And so, most of the time it's like, hey, I want a number. We give them a number. A few months later, they show up and they're like, I kind of like that idea of what you talked about. Can we talk about that more? And about half of the people that come back after those few months then get engaged with us, and we do transfer their processes and business through data.
Yeah, that's kind of probably the secondary to this is, you can put them into practice, but there's a lot of internal transformation for the entities that are involved.
Yeah.
Also on your side, to make sure they can curate on their side, so they can probably also author that data, validate it, check your models, because to some extent they kind of have the business end of it. They know their business better than you. To some extent, they'll be your peers to interpreting the data, to making sure you're on the right track, to see, does this match your gut feeling to some extent? Kind of.
Yeah,
just not having a model in the wild.
It happens all the time, just like you said it. We get into projects or programs, and we're working with people and we're building models, and then someone will raise their hand and go, that's illegal in California. And we're like, oh, I didn't know that. So then we'll pull all the data for California out, and we'll rebuild the models, or there's some kind of export regulation that we can't do that in Romania, or something like that. We're data and analytics professionals. We don't really understand at a deep level everything that we're getting involved in. That's why we need the subject matter experts to let us know. It's like, hey, you can't do that. that's illegal, that's regulated, or whatever it is.
Yeah, for sure. For international law is very, very complex. Okay. Another question. What do you think is the role of ML in pharma and analytics, maybe in general? What should and shouldn't be done in that space? Because it's very people oriented. It's very like owning data. It's very touchy-feely concerning like genetics, what do you own, things like that. So what do you think the role of ML is there? How much is
Yeah, in the pharma industry, I think AI and ML has great applications and will help us in many areas. A lot of people don't think about it, but pharmaceutical companies are just like every other company. They have manufacturing, they have sales, they have pricing, they have distribution. All of those areas are fertile lands for AI and ML applications, and we do a lot of work in those areas. Most people think of the areas that you were alluding to: genetic data, diagnostic data, healthcare prescribing data. Now those data have very specialized care that you have to take around them. And we do that too. There's a big change in the world, a lot in the UK, a lot in the US. Those are the ones that I'm most aware of. Rare diseases are proving to be a very interesting area for the analytical community as well as the healthcare community. There are data commons and data exchanges and pooling of data. People that have certain rare diseases, we're getting to a point with some of them where we have a census of the data. We have a census of their prescriptions, their diagnostics, and in some cases, we're almost reaching a census level of their genetic data. So these rare diseases, these people are hugely invested in it because it has such an impact on their quality of life. They're donating all this data, and analytics teams are working on it, and they're looking at an entire census from many different perspectives of what these diseases are doing to these people and how they can live better lives. We're getting to the point where some of them have very promising tracks that could lead to genetic modification, which is very controversial, but if it works, these people will never have to take these drugs again because they'll be cured.
Yeah, that's kind of the idea, with the advent of CRISPR-Cas9 and their way to also like have meaningful modifications of some very, very bad conditions, and also to the way we kind of look at protein folding on alpha fold and everything. So this is so you kind of also see it in that space in which will be able to model things much better to some extent using it. Okay.
Yeah, it's really interesting. It's very intriguing, and it's quite. Yeah, it makes me giddy. I'm so excited. I'm so happy about this that you could have a disease that affects 5,000-10,000 people, and you could practically get permission from every one of those people, where you could say, this is what we're going to do, and they all raise their hand and say yes. All right, well then everybody's opted in. Let's go.
Oh yeah. Okay, that's quite interesting. Yeah, to think that you can actually get to the people and have them opt out and really like volunteer. That's really like.
Say, I'm in. Let's go for it. Find out what you can.
Okay. Okay, another question. So neural nets kind of do not provide any kind of guarantees of correctness for their prediction. The way we deal with this from a theoretical point of view is that we assume a stationary distribution. In practice, we kind of rarely can ensure that. So you end up applying a model and out of distribution data. How does this really play in the pharma settings?
Great question.
How do you envision, kind of ML here?
Yeah, great question, Gabby. We all probably are aware that neural networks, are in the world we live in right now, are pretty much synonymous with ML and AI. You really go down that line and everything's a neural network, a reinforcement learning, a concurrent neural network, a generational adversarial network. It's all sorts of derivations down there, but it's for the most part neural networks at this point. I'm hoping that we get past that with some other techniques that give us more predictive power, but this is where we are. And as you said, it's hard to understand what a neural network is doing. A multi-million layer neural network, I mean, really, how can you make sense of all the tuning of the hyperparameters and the decisions that are being made in those hidden layers? It's very difficult to impossible. The way the world has treated it right now is that we cannot use our most powerful techniques on our most intractable problems.
Yeah.
So in the United States, we highly regulate financial services, we highly regulate pharmaceuticals, EU as well, not just the US. But for the most part, we can't use neural networks on those problems because we can't explain what they do. Now, there are a handful of companies in Seattle and Silicon Valley that are building XAI, explainable AI, add-ins and layers for neural networks. And what those are, they're additional algorithms and approaches that once you train a neural network, you then use the neural network as an input to these systems. And then those systems actually output mathematical models that explain what the neural network is doing. So I am predicting that in the next 18 months, we will have workable, explainable AI. What is the implication of that? If it works as well as I expect it to, we should be able to use neural networks on all the problems in those regulated industries and submit the answers from the neural networks, the outputs from the neural networks, and the explainable code from the XAI layer to the Federal Drug Administration, to the Securities Exchange Commission, and all those people that regulate these industries and say, okay, we have better explanatory power, better predictive power, and we have deep explanations of how it came to be, proving that it's not racist or sexist or discriminatory in any way. I think we're well on the way to solving that problem.
Okay, that's probably for the approval step, like you said, FDA, SEC, kind of that side of it. But also, how, for example, do you see, how are we going to live with the current systems, kind of, because to some extent, do you see something like, do we envision the use of ML like to make proposals that are validated by humans, like human in the loop, human on the loop, like some kind of aid systems? That's going to be the first generation. Because even if we have explainable AI, which to some extent I kind of agree with you, we're definitely there. We're definitely building better models that are explainable, that are kind of synonymous with those. There's still going to be a lot of time until we kind of probably will have them. So in the meantime, in the pharma settings, for example, how do you see coexistence, with the current unexplainable system? Do you see any, or do you think it's very complex of an issue?
We're getting guidance from the FDA that they want us to use more and more powerful analytical tools, but we still have the guidance or the law or the compliance burden that says if you have a model, you must be able to explain it. So the current status quo will hold until the laws are changed, and I don't see that happening for the next 4 to 5 years. So, we can't use our most powerful models on some of the problems because the government won't let us.
Okay. Now a really quick question. Is analytics as a service the future of data science?
Say that again?
Is analytics as a service the future of data science? Do you see it moving towards that space, or you kind of still see it like the way it is now?
I think there's a market for that. People tend to like to think that the pendulum is going to swing all the way over or swing all the way back. I don't think we'll see the marketing swing all the way over. That's for sure. But in reality, there will be a spot where analytics as a service is an offering. We already see it in Salesforce.com with Einstein and, with other platforms putting in AI and ML subsystems and recommender engines. We already see it in Netflix and Facebook and Amazon, and there's analytics as a service running there. We're just consumers of it. Now, businesses will go to, probably in the beginning, they'll go to EY and Bain and McKinsey and consulting shops like that, and they will do analytics as a service for them. Over time, it will broaden out and it'll take over, I don't know, 10, 15, 20% of the market. There are a lot of companies out there that say, they're pharmaceutical companies. Let's stay with that industry for now. They say, oh, we're a pharmaceutical company and we make pills and drugs and therapies, but we're really a data company. Well, that's kind of a silly thing to say. You're not a data company because you don't really understand data, and you certainly never will become an AI company, but you hear CEOs saying those ridiculous things. But those are the companies that will go to these big consulting shops and ask them to handle their data and analytics needs. Because number one, they don't understand people like us. Number two, they can't pay us enough. And number three, they can't retain us. So, I think those companies at some point in the future will realize that they're better off having a third party do their analytics than trying to build it internally.
Okay, yeah. It kind of seems like the same thing. It's the same way people are looking at auto ML right now. There are people that have just some data, you just put it in, you press a button, and there are some predictions. But yeah, you're right. Probably the more you kind of go towards really deeply understanding your data and deeply identifying what people, more like most algorithms, are kind of blind to or don't see, or identifying trends and things like that, it's going to be much more hard to justify analysis as a service in which it's a lot of domain knowledge there that just can't appear out of nowhere.
If you look at some of the best research which comes from McKinsey, the leading companies, which is the top 7 to 10% of companies in each industry, are building a lead in those industries with data and analytics teams. They're investing in it, they're deep in their data, they understand the technology, they know what they want to predict, they know how to take market share from their competitors. Those people will continue to extend their lead and hire every data science graduate that comes out of every good university around the world. They will not probably use analytics as a service because they understand the absolute competitive advantage they get from understanding their data and using analytics at a deep level in their operations. The companies that are one step behind them, the also rans, or the not the leaders, but the followers, they will use analytics as a service and they will get benefit, but they will never catch up to the leaders. And then there will be the rest of the companies, which are the laggards, which are still asking themselves, does data work? Can we use data? Is AI sensible? And those
save our data.
In my opinion, those people are just lost. There's nothing that you and I can say to them.
Yeah, definitely. It's definitely an eternal journey to either the market teaches you, or an eternal, moment for a company to look inside it, to have a moment and say, listen, we really need the help. We really don't understand it. We really should collect this. So yeah, I've actually seen companies that are very big and just say, we don't need this. We're so good at our business that we just don't.
Right. Yeah.
And you don't really know what to say to them. Are they in a Nokia moment in which 2 years from now they might not be there? You don't really know, but
yeah. Are they Blockbuster? It's like,
yeah.
Do you really believe this? I had a conversation 2 or 3 months ago with a manager in a company. I was at an event, and she came up to me and said, oh, I've been doing this for 30 plus years and I know the business, and this whole thing of using data is just a silly waste of time. And I just smiled. I said, well, in my head, I thought, I hope you enjoy retirement because you need to do that soon.
Yeah, probably. So yeah, going to another question is a bit related. How important is business intelligence for a company nowadays? How much should it be in that space for it? BI mostly.
Business intelligence is table stakes. That was something that we were doing 30 plus years ago. Dashboards and key performance indicators. You need to understand, did we do better this month than we did last month? Did we sell more, Persil in, Bucharest than we did Budapest? You need, to understand the basic performance of the business, but that's pretty much table stakes at this point. If you're not doing that, then you probably really don't understand the business at all.
Yeah, but it has a weird effect in which the more you find this as a metric, the more you have KPIs and dashboards and things like that. People optimize for that rather than value, quality, things, innovation, things that really can't be measured by a dashboard, So
yeah.
In that sense, how important is to be really BI driven than to also be kind of, looking a bit ahead over your shoulder, out of the dashboard kind of.
Yeah, it's a great question, Gabby, and it seems very simple on the face of it, but it's multifaceted, to tell you the truth. I have built an analytical maturity model that starts out with raw data, integrated clean data, business intelligence, descriptive statistics, predictive analytics, prescriptive analytics, simulation, and optimization. And you can't skip steps. It's all linear. You have to go through one to get to the other. So if companies have to go through the data and the BI phases, but they can get distracted and they can stay there. And that's fine. You'll understand your performance in a rear view historical perspective, but you will never get to the potential and the promise of data and analytics. So, when people get enamored with business intelligence, I kind of shake my head and I said, well, you're just 2 steps away from the very beginning. You still have 8 or 9 steps to go to get to something that's useful. So if people get stuck on BI, then okay, well, they'll get some value, but they won't get all the value, and they won't have a proactive business that they actually could have.
Okay. Now we'll move to some lighter questions. What will your advice be for someone wanting or just starting a career in data analysis and or AI? What do you
Well,
think? It's
yeah,
their approach.
I have some friends that don't agree with me on this, but I'll say what my opinion is. And, I believe that, young people should go to university for a very technical degree. I think they should go to undergraduate for engineering or math or physics or some hard science like biology or chemistry. I think your undergraduate degree is a place for you to build your technical foundation. And after that, then you can go, get an MBA or fine arts degree or whatever you think you might want. That's the first step. If you're a young person, go get a degree that makes you really use your brain in your undergraduate. After that, then, go find an organization that allows you to do experimentation and build some really interesting models and things like that. And then find people that you resonate with, find a community that you can be part of and talk to and share ideas with. We, as part of our interviewing cycle, have people take home tests and do tests. And people say to me, oh my God, they're going to cheat. You're not sitting there and watching them. And I said, look, at work, I don't sit there and watch them. They can call people, they can call friends, they can go on the internet, they can find code snippets. I don't need them to sit in a room and prove that they're the most brilliant person ever. I need them to prove that they're creative enough to solve the problems. I don't care what resources they use. So it's kind of what I would say is get a good degree, find a place that you think is fun to work, and find a community that you want to be part of.
Yeah, probably that kind of also answered my next question. It was how important is a solid math background for someone wanting to start in data science or in analytics? Quite
You need to
important, I
understand
guess.
math.
Yeah.
I mean, you need to understand at least algebra, maybe calculus and trigonometry. I mean, you can't get away with arithmetic, that's for sure.
Okay, fair point. What does the future hold for analytics? What are the hot areas for research and development we should keep an eye on?
Yeah, there's XAI, explainable AI is huge right now. I think it's gone beyond research into practical implementation. There are some, as I said, some startups doing some really interesting things. If anybody in the group is interested in reading, I would recommend you read Judea Pearl's most recent books. He's doing some really innovative work. He's 80 years old or 80 plus years old. He's a irascible old guy, but he has created a whole new branch of algebra to understand causality. We in data science are really good at correlations. We understand correlations and we're pretty good at it. And we can look at a problem space with thousands of variables and come up with a few variables that have correlation. We're really bad at causality. Judea Pearl's work is actually bringing forth math that will allow us to have a better chance of understanding causality. And his work is still in the research phase, and there's only a couple companies trying to commercialize that algebra at this point. So I think that's really exciting stuff to look at.
Okay. I'd like to, yeah, so if you have a reading list, please give it to us and we'll publish it afterwards. Yeah, definitely I've seen a lot of talk about this and also about this idea of how much more can we add like causality or probability in the foundation of the languages themselves. Python is quite a good language to like express things easily, but not necessarily strong typed or, somehow within a path in which you kind of get easily, you kind of can do multiplication, other things, vector tensors, but you can't really do a lot of let's say Bayesian things really
That's right.
easy. So
Right.
that's like a really good, yeah, a really good direction to go to, I suppose.
Yeah, another thing that, since you brought it up, Gabby, is Bayesian. I've always been intrigued by Bayesian, theory and practice. I've got a guy on my team who's a really great Bayesian mathematician. If you're looking for a way to differentiate yourself, really get deep in Bayesian and understand it. I don't think we use it as much as we could or we should. I think that's an area of specialization that if you really understand it and you're good at implementing it, you'll be able to get work anywhere.
Yeah, I totally agree. I think it's a really good idea. So yeah, a really fun question. Can you predict the stock market? But take it a bit like a broader question.
Well, if I was able to, I wouldn't have a day job. So there's your answer.
Yeah, okay, fair enough. But what do you think it's really missing? Is it too much noise? Are we don't have enough compute? Don't have enough data? Is it not even a thing we can do because we can't even
No,
model it?
it's such a complicated environment. It's so multifaceted. A good friend of mine, a guy named Bill Janeway, probably the most successful venture capitalist in the world ever, said that people that are looking at first derivative effects always miss that the important work happens at the second derivative. So, not only do you have all the complexity of the markets and the people and the companies and the globe and the climate and everything else that matters, you got to get to the second derivative before you actually get to the real work. So it's just really hard stuff. And I haven't seen anybody be able to do it.
Yeah. Okay, so even if we're a bit early, I'd like to give you the opportunity to give us some closing thoughts. Whatever you'd like to share with us. I know you're a bit of a
Yeah,
strict.
absolutely. I was really pleased when you guys reached out to me and invited me to be part of this forum. I do my best to try to talk to people in all parts of the world. Last week, I was talking to some people in Brazil. Before that, I was talking to some people in Australia. And when I got an invitation to address a group there in Romania, I was so excited to do it. The bottom line is I do get people asking me with fair regularity, and I'm always surprised when the question comes, when is all this going to be done? And I say, well, it's math and it's data, so it's never going to be done. And for some people, that's really exciting. And I hope the people that are listening in today find that exciting, because your career will go on forever. Your career will go on as long as you have curiosity and energy and want to do it. Other people, that's depressing. They're like, oh my God, this is going to be something that's going on the rest of my days and my children's days and all that. And that is true. And I find that exhilarating. And a career in analytics is really exciting because you get to work on so many different problems. When I was working at Dell one day, I was talking to a plant manager about the optimal flow of oil through a plant that was making mayonnaise. Then in the afternoon, I was talking to a Danish bank about how to calculate the optimal credit risk. So what other career can you do that? Where can you be talking about supply chains or price or oil or manufacturing or, the blast radius of a bomb or whatever it is? There's so many things that we get to work on. My wife just laughs at me. I come down and she's like, what'd you work on today? And I tell her and she's like, oh my God, I don't even want to hear it. Because I'm always talking about the craziest stuff. And I find that exhilarating. I find that fun. So hopefully you do too.
Yes, thank you very much. Thank you for being with us. We really valued this interview. Please share with us, your reading list or whatever future predictions. We'll publish them. We'll definitely is interesting.
Yeah.
So
Well,
thank you very much.
Everybody find me on LinkedIn and link up with me. I link up with everybody in the data and analytics community. So happy to have conversations with you one-on-one or trade emails or messages or whatever it is. So have a great evening, everybody. Thank you.
Yes, thank you very much.
Take care.
Thank you, John.
Bye-bye.
Thank you very much. Bye-bye.